hopefully you didn't come expecting a deep legal and policy analysis, but we assume that those are the sorts of work that you are well capable of doing. Our goal here is to try to focus on understanding how industry, understanding how government, understanding how data is actually used across different sectors. We started about a month ago with a focus on machine learning. If you didn't catch it, it's available online, so you can catch up. And then today, of course, we focus on location. Our next topic is going to be the nuts and bolts of ad tech. Obviously, always an issue of hot debate, but an issue where the nuts and bolts aren't always so obvious. And so we appreciate you joining us. I'm pleased to welcome Paul DeHert. Paul, probably a familiar name to you all for his leadership and scholarship at VUB, and we're delighted that VUB has been partnering with us on this effort. And so, Paul, I hand over to you for some welcoming words.
Yes, thank you, Jules. Ladies and gentlemen, very short. I just want to express my admiration for the work of Jules and his team. It is a kind of work that is very much needed in a city like Brussels. We're a regulatory capital. Most of us are lawyers, or we become lawyers, or we are forced to become one. And I think that is a limit to our understanding of the world, because that is one sort of expertise. And I'm very happy that Jules has opened up doors to other areas of expertise, because of course, as lawyers and as others, we know that our regulatory understandings are influenced by the advances or the possibilities of technology. So it is with great admiration that the Brussels Privacy Hub is teaming up with Jules. We first did 2 academic conferences together, but I think this series of workshops is very important in the light of what is there on the market. And I think these kinds of events are not on the market. They should be on the market, and the way they have been proposed here are a nice example of how we should approach these things. The first workshop was held also in Brussels during the international conference with the data protection authorities around. It was a big success. The materials are available, as Jules said. And what I think this line of interrogation will bring us somewhere, but where, I don't know. And that's why we have so much trust in this partnership, because I don't think with Jules we will go in the wrong direction. I think we will go in the right direction. And so happy to be there, happy to partner with Jules and his team, and voila, the floor is yours.
Thank you, Paul. I feel I've got a high obligation now to live up to and not mess anything up, so thank you so much. Stacey, do I get to introduce Simon? Any housekeeping that we should be sharing? Folks who are remote, we're keeping an eye on the chat space, and you will also be able to, as we break, ask questions, and we'll bring them in. People in the room, we may try to rush over a microphone so that, because if you speak from there, the remote audience won't be able to hear. Later on, when we tape and record, we'll make sure that we don't have you asking the embarrassing or brilliant question. There are no embarrassing questions without you being comfortable. So we'll be careful about how we edit and contact if there's anything to be included. Okay, I'm delighted to introduce then Simon. You're going to be our lead off. Simon Hania. Simon, a well-known figure to many of you who've followed the nuts and bolts of data protection for a long time from his privacy leadership days at TomTom. So obviously for him discussing location, when location is sort of the beginning and the end of what obviously companies like TomTom are doing. Simon today is the DPO at Uber, where obviously data and location data, again, essential and critical. And so Simon will kick off. We'll turn, I'll just so you know who this wonderful woman to my left is, Selke. Kara is at StreetLight Data, which is a company that uses data for a whole range of interesting insights and analytics, and she'll explain as well details about how the industry works, and they'll both take questions. Simon?
Thank you.
You are targeted.
I'm mic'd up. So this is what we're going to talk about, and I'll take the first part and we'll be talking about the last part as well. If you have any questions, feel free to ask, especially when I'm unclear or when you want to make a real thought-provoking question or put me on the spot. That's fine. As Jules said, I'm DPO at Uber and before at TomTom, where location data is a lot of part of the business, which means that I also should explain to you that I'm not a lawyer, I'm an engineer by training, which means that I should know all about this and maybe less about the law. So I will refer to great legal minds for that part. We're going to be rigging this up a bit differently. What I wanted to talk to you about first is what is actually location data. And I cannot do that without first also explaining a bit about what the basis is of location. The basis of location in all cases is a geobase, also known as a map. Now you all know maps. You may have even used them in your car previously. Those were drawn. But actually a map is a database of objects organized in a way that you can actually use it to pinpoint these objects and to be able to actually use them. It takes a lot of work to create maps, and they're made by actually ingesting data which could originate from individuals and then manipulating it such that it becomes useful to display or to put layers on top. For instance, a layer that allows you to navigate on top of a map. It could also allow you to have a layer on top which depicts things like traffic information, shopping malls, but also individuals. So that's a key layer. Stacey, how far are we? Because otherwise my picture is... Okay. It seems we're using Zoom, and that's always a bit of a challenge. So this is what I was talking about to you. And one of the key things, and this is why it's relevant to get this understanding, one of the key questions that is being asked to a mapping database is, tell me what is on this location, or tell me what this street name it means in terms of a geo-coordinate. Maps are being asked this question gazillion times a day. Every time you type in a location, that location is converted into a geocode, which is latitude, longitude. Or you can enter a latitude, longitude, and then the map can tell you what's around that position, depending on how rich that map is. And this is a key component which relates back to finding individuals, identifying individuals, and so on. What is relevant is that you have seen a map in its visualization, but that's just a visualization based on different data. To give you an example, if you have an Apple iPhone, there happens to be a map in there called Apple Maps, or you have downloaded Google Maps. If it's Apple Maps, actually the data underneath is maintained by Apple based on data they source from companies such as TomTom, and Google built their own map. So it's a different map. Actually in the world, largely there are 4 players that build maps, only 4. It's a company called TomTom, the company called Hania, which is owned by a couple of car manufacturers and Intel and a few others. You have Google, and there is an open source, an open street map, which is actually pictured in the corner, which is for free, which you can use. Normally you license the map, and that's it. Creating and maintaining it costs a lot of money. That's why there are only 4. But it's very fundamental. So that's just to get you an idea of that. A lot of the data on top of the map are just layers on top. Okay. Now we go to location data. Now you may think that location has just 3 dimensions. Latitude, longitude, and altitude. X, Y, and Z. But actually, I think there's more to it. I'll go into that in a minute. First, about latitude and longitude. It's good to know that on the map, which of course, Earth is a sphere, and we kind of crush it to create a map that in itself creates distortion. Won't go into that now, but effectively, years and years ago, for shipping purposes, we have this system in which we have horizontal and we have vertical. This is what we call the longitude from the zero, and the zero happens to be what we agreed to be across London, Greenwich. That's the zero. So we have 50 degrees east, and for instance, 40 degrees north, up north, and that's the longitude and the latitude. And then we add the direction east and north. So that's how that works. Height is just a number, say in kilometers, and that's the core of location data. But location data, when it is about objects, especially when they move, you will want to have an additional element to it, which is a timestamp. That's relevant because currently I'm here at this location with this timestamp. Now I'm here. That's a different coordinate. So it's 4 dimensions. Another element to take into consideration of location is how frequently we sample the location, for instance, of an object. If we do that 10 times a second, we get 10 times Simon is here. The same place. If we do it less frequently, every 24 hours, I may have been here, gone away, come back, and I only have it 24 hours later. So there is a level of granularity there to take into consideration. The third one is precision or accuracy. As we will see when we go on into the technology part, you will see that the accuracy of location is a key thing. People think of this blue dot on the map as being accurate. It's actually not. If you look at your smartphone, you will in many cases see a little circle around it, which gives you an indication of the accuracy. That is where the phone or the system says this is where you could be. It's not necessarily where you are. And this is also relevant because it helps to determine, well, indeed, accuracy, but also if the accuracy of my location data is 2 meters, where I'm now and where I'm here could look the same, but isn't. So this is also a relevant consideration. Maybe not so much in advertising, but it is when you start to build self-driving vehicles. You need highly accurate location. So that's about the dimensions to keep in mind. I'll just give you an example of this. So last May, I think it was, someone made a trip. You can't see who did this. Actually, I was in Berlin. And here you see an example of latitude and longitude in a certain way of writing this down. And by the way, I retrieved this from my own account using the data portability features that exist. And then I plotted them on a map. This is what the Uber app shows me, where I've been, from the city center of, well, you could maybe recognize it, but this is Berlin, to the airport. Hotel to airport, actually. Now, if you go to the detailed trace, you can see a lot of dots here. These are the blue dots. So here you see a sample rate, here's frequency. I've myself decided how large the dot would be. This suggests an accuracy, but the accuracy is actually not available. And what you can see here is how this works out, and I've done 2 plots. The red one is what actually came from the GPS sensor in the smartphone. And as you can see, I was in a building, it looks like, or collided with, which couldn't be the case. I was probably on the road. So this is corrected for the road, map matched. That's what sometimes also happens. Here you can see, actually, this is the hotel. I was standing outside, got into the vehicle, and then it had to be corrected. So this is what you can see. I know this because I've been there. I've now told you, so you can now know this was me, but realistically, if you just have this data, would you be able to identify me? What would you have to do so? That's a key question. So here you can see how this set of data, captured using a smartphone, can be represented in different ways and giving rise to different views and interpretations. But this is the only raw data that was available. So this is location data in general. Now we move to the next topic, sources of data.
Questions before we do?
Yeah, that's fine. Any questions? Yeah.
Was that the actual number of digits that were available for your latitude and longitude? Was it available to that level of granularity?
Yeah.
Okay.
So I did not truncate or do anything different with this.
Okay, thank you.
So this was a lot. But bear in mind, what I did not add here is the actual accuracy. So it suggests high accuracy, but it may not have been as accurate as to this level of details. We don't know. We could know if we had the information from the smartphone, but I don't have that currently. Yeah?
There's one question from the remote participants.
Yeah.
The question was, Gabriella, the question from the remote participants, how many decimals there is necessary to identify a person? I think that's a complicated question, but maybe you want to say another point or two about that.
Well, I would actually say, so let me give you some of the facts. So this is a hotel starting point. That one is the airport. So it's difficult to do that from the beginning and the end. So if you only have this trace, and the locations are venues where multiple people can be, then you need additional information to be able to identify me. So I should tell you at what date this was, and what venue, and then you probably can find out that I was a speaker at a conference by going to a website in Berlin, and then you may be able to infer it might have been me, or anyone else also at that conference. So it is not necessarily the fact that the data is highly accurate. It could be very, very accurate, but if the data describes, like it does here, just a string of dots without the additional data I was just telling, then you would still not be able to identify me. So it's not only the accuracy. So to go back to the question another way, if I am the only one who is in a desert in Australia looking for minerals, no one else, having that string in itself may already identify me because I may have had a permit to go there. And then it even doesn't matter that it's highly inaccurate because there was only one individual in that vast area. So it is very contextual.
Challenges of the identification of location data, but I guess you can sort of see the complexity in that it ends up being so context specific. But if you, at the end of the day, are charged with somehow, aggregating or doing other analysis, it'll be a legal question as much as a technology question.
So just one other way to look at the question, to be able to identify, it depends on, amongst others, these elements. So latitude, longitude, precision, but also frequency, time, and actual where were we on the globe. Okay, let's move on. Sources of data.
This is mostly not so much so that the people in the room can hear me, but so that our friends on the live stream can hear me. Quick other housekeeping note before we move on. This is a pretty long session. We have a lot of content to share with you, and we're going to stop pretty frequently for Q&A and hopefully have a really interactive session. But also, you are more than welcome to stand up walk out at any time, come back, we will not be offended. Rather than, I think, us stopping for a long break somewhere in the middle, we'll just rely on you to come and go as you like, and there's coffee and water and all sorts of things right outside. So, sound good? And big thanks to the folks on the live stream for joining. So, my name is Stacey, and I thought that the best way for me to set this up for Selke and Simon Hania to share some of their expertise with you would be to talk first about what we're really talking about with the sources of data. And we're really talking about a pretty wide variety of sources of geolocation data. So most people, when we're in the context of consumer privacy and law and policy around consumer privacy, we're usually thinking primarily of the consumer smartphone, right? So this contains an increasingly sophisticated and increasingly high number of hardware sensors that are used for outdoor and indoor positioning. And all of these feed into platform controls that are usually best known as location services. In addition to that, there's a lot of connectivity information that I'm not going to spend quite as much time on today, but just to flag it. So mobile cell carriers, for instance, by virtue of providing the service that they provide, typically know where the devices that they're providing service for are located because of where they connect to. And then as a final note at the end of this, I'm going to talk a little bit about what we mean by Wi-Fi analytics or mobile location services, which is kind of the opposite approach. Rather than a smartphone inferring where it's located, we're talking about sensors that are inferring where smartphones are located in a public space. So smartphone location services, I think, is a great place to start because it's what people are typically most familiar with. And by the way, people on the remote Q&A, feel free to chime in at any time, and our friends in the room here will let me know if you have a question. The operating system by which I'm talking about iOS or Android of most leading smartphones totally controls access to that device's geolocation. So the apps, the websites have to go through the operating system typically to get user permission to access the information from these sensors. But location services itself is actually far more than just GPS. So it aggregates data from many, many different sources, including satellite information, but also nearby cell towers, nearby Wi-Fi networks, Bluetooth, proximity data, and all of this information from the various hardware sensors combines together to enhance and create a more accurate latitude and longitude. So, quick list for those of you who aren't super familiar of all of the various different hardware sensors in a typical device. This is an iPhone 7, just by way of example. Many of those, far more than GPS, can be used for location positioning. And over time, from the first smartphones, 5-10 years ago when these were first in development, the number of sensors in a typical smartphone has increased pretty dramatically, from 3 or 4 to now 14, 15 ambient light sensors, all kinds of things to make smartphones more contextually aware, and they've also become more sophisticated. All of these mobile sensors in aggregate generate the input for operating systems to provide a standardized latitude and longitude like Simon was talking about. So location services will aggregate all this information together and spit out the output of a latitude and longitude to apps that request it, or the SDKs or software development kits that power those apps and request it through the app. Question? That's a good question. I think it has more to do with, over time, because of an increasing privacy awareness on the part of the operating systems, a sensitivity to what most users' expectations are. And that has legal implications too, as most people know, but I suspect that's mostly it, because what we've seen over the last few years is operating systems taking more steps to cut off sources of information and essentially force apps to go through location services rather than accessing the hardware sensors directly. User sensitivity, I think.
It's more of an industry standard approach, basically defined by Google and Apple on the fact that to access the data, and they provide data at, I would say, the best accuracy they can provide, using additional sensors. For instance, if GPS isn't good enough, because, for instance, when you're in an urban canyon, as it's called, your GPS may be off or inside, so they have additional technologies to do that the best at availability. The apps effectively are asking permission to you as a user for Google to expose that to the app. And how they subsequently use it is up to the app.
It's a good way of encapsulating it. But as you can see kind of from this diagram, having just a latitude and longitude itself probably wouldn't be very useful. So, you know, as most people will be aware, they'll typically attach an identifier to that stream of data in order to keep state over time with that same user's geolocation. Otherwise, you would just sort of have a stream of random latitude and longitudes. Most commonly in the commercial smartphone ecosystem is the use of an identifier known as the advertising identifier or the ad ID. IDFA in Apple, ad ID in Android, essentially functions the same way, looks about like this. This is a random one. And so that will be sent along to by request of the app. And just as a quick side note on the mobile advertising identifiers in Android and iOS, these are also typically linked to an operating system control known as limit ad tracking. This is another point where most smartphone users are pretty familiar with what, at least have seen this, but might not necessarily know what it does. So in iOS, for example, if you toggle the limit ad tracking flag in the privacy settings of the phone, the operating system will zero out this advertising identifier so that latitude and longitude might still be sent, but the advertising identifier, instead of looking like this, is going to be a string of zeros. Most operating systems also, typically with the permission of the user, will send the data back to themselves in order to enhance their services in an ongoing way. And as a final note in this story, you might be wondering, you know, to get back to that question a minute ago, can apps ever directly access the data from the hardware sensors and sort of do an end run around the operating system location services? And the answer is typically no, because operating systems have taken steps to cut off these streams of data, with a couple exceptions, but for the most part, no. So to dive into a couple of those things a little bit deeper, I thought I would spend a couple of minutes on GPS, cell towers, Wi-Fi, and beacons. Basically all of the fun stuff before I turn it over to Kara for some case studies in this. And so we'll just dive right in. GPS is probably the one that most people are most familiar with and often conflate with location services as a whole. So when we're talking about GPS, that's really the United States version of global navigation satellite systems. In the EU, you have a system called Galileo, which will be fully functional by 2020. Russia has a similar satellite system, right? So these satellite navigation systems allow devices to hear the time-stamped signals and determine their pretty reasonably accurate latitude and longitude using the time signals that are transmitted by those satellites. Now, as Simon mentioned, there are some major challenges to this. The first is that it's pretty much line of sight. So if you've got bad weather or you're in a pretty dense urban environment with lots of blocking of signals from buildings, GPS is really not going to work very well on its own. So it doesn't work well for indoor positioning, doesn't tend to work well in very dense urban environments. So lots of other things have sprung up to kind of meet the need of GPS not working particularly well in all contexts. One of those is cell tower IDs. And I should probably stop here and say that most of what I'm describing has to do with something called anchoring. So if you are a smartphone or an app connected to the data coming from a smartphone, the easiest way to position yourself in space, aside from reading the signals coming from satellites, is to look around you at other connected devices that have known locations. So one way to do that is to look around for radio signals coming from cell towers, because cell towers are pretty easy to map and compare the information that you're seeing with what you know to be the location of those cell towers, right? So there are plenty of publicly and privately available databases of known cell tower IDs. These grow every day as new cell towers are added, for example. And if you have access to one of these databases, you can look out, see the radio signals coming from nearby cell towers, see the signal strengths from more than 2 or 3 cell towers, and have a pretty good idea of where that device is located. Pretty straightforward. Wi-Fi networks work pretty much the same way, and this is one that's often not known by people when they're working with location services on their smartphone. You might notice, for example, if you are navigating using Google Maps or some kind of other service and you have Bluetooth and Wi-Fi turned off or disabled on your phone, you might not be getting very accurate positioning. That's probably because the device is relying primarily on GPS. You'll find if you turn on Wi-Fi and turn on Bluetooth, the accuracy goes way up, and that's because one of the major signals feeding into location services is the existence of nearby Wi-Fi networks. So starting maybe 5-10 years ago, major service providers started mapping the existence of all the known Wi-Fi networks. And this could be anything from hotspots to free Wi-Fi. I've got an example here of a Seattle free Wi-Fi hotspot. The map here, which I generated last night from one of the common service providers, is actually a map of the aggregated Wi-Fi hotspots in and around the Square Conference Center where IAPP Europe this week is being held over the last 2 years. So each of those purple dots corresponds with some public or private Wi-Fi network. Could be a home network, could be a coffee shop, whatever it may be. And to look at that more specifically, and sorry if you can't see a little bit about, of that, but more specifically what we're actually looking at when we're looking at the signals from Wi-Fi networks are the names of the networks, although that's less useful because those tend to change, and they also tend to have privacy implications, right, if I've named it Stacey's Wi-Fi network. More useful is the BSSID or the MAC address, which looks like this on the second row here. So if you can compare the signals, again, just like cell towers, that you're seeing from a device against a database of known locations of Wi-Fi networks, you can get pretty accurate location data from that. Bluetooth is another one. So the last couple of examples have had to do with databases of known locations of cell towers, Wi-Fi networks, whatever it might be. Another really useful way to do this in maybe a more customizable way would be to deploy something called beacons. And beacons are, when we're talking about beacons, we're usually talking about things that look like this over here on the left-hand side. These are very inexpensive, $10, $15 radio transmitters. They've got a little shell of plastic, and they just got a little battery, and they send one-way radio signals on the Bluetooth spectrum. So if you have Bluetooth turned on your phone, you can typically detect the existence of nearby devices the same way that you would detect, you know, a Bluetooth speaker or something in your home. So because beacons are so inexpensive and they just sit and send little unique identifiers, you can deploy them in spaces where you're interested in getting pretty detailed proximity data. So for instance, beacons are pretty commonly deployed in retail spaces. So maybe you don't need to know the exact latitude, longitude of a person's device. Maybe what you really want to know is whether that person is standing in front of a particular aisle. And if they are standing in front of a particular aisle, your customer loyalty app could detect that and send a little notice that says, hey, these things are on sale, right? Proximity data, it can be incredibly useful. It could also be sort of reverse engineered into precise geolocation or latitude, longitude. But it works in sort of an opposite way that you might expect. Rather than beacons collecting data about you, it's really the beacons that are sitting transmitting one-way identifiers, and phones with Bluetooth are equipped to receive and read those identifiers. As a final note, I mentioned earlier that most access to hardware sensors is governed through geolocation, through location services on the operating system. Here are a couple of examples that come from emerging alternatives in the last few years to gather proximity data that involve the use of light and audio. And these are very interesting use cases to me, and I'll explain briefly how they work. I should note they're not very common for reasons that hopefully will be pretty clear. So in the same way that beacons can send a unique identifier over the Bluetooth spectrum, or Wi-Fi networks can send their information over the Wi-Fi spectrum, you can send an identifier in many different ways. So one way to do it would be to incorporate LED communications into a light fixture. This would be something that existed within the realm of visible light communication, but wouldn't be something that you would see with your eyes because it would be happening too quickly. And a device with a camera turned on that was equipped to be listening for that kind of identifier would be able to detect it and infer its proximity to that identifier, right? The challenge here, of course, is you have to give your device access to turn on your camera and do this, and not many people are probably going to do that, and so this probably hasn't, for that reason, gotten a whole lot of traction. The upside is that because light travels so quickly, you can get accuracy with LED alternatives to within millimeters, which is pretty interesting and maybe useful for certain retail contexts. Audio works in essentially the same way. The concept of audio beacons gained some traction a couple of years ago. Again, fairly rare because it would require access to a device's microphone, meaning the user would have to grant access to it. But you can design a unique identifier that transmits over the audio spectrum, just above the normal range of human hearing. So for those of us who are a little bit older, if you remember the sound of a cathode ray television, it's pretty much what audio beacons sound like. And these feed into really precise proximity data. As a final note, before I maybe take some questions and turn it over to my colleagues, I should mention this concept of mobile location analytics. So up until now, all of the examples here have been about how a device gets access to or infers its own geolocation. What I sort of think of conceptually as the opposite of that is how sensors in a given space can look out into their space and detect the existence of connected devices. So any device that you're carrying, typically a smartphone, but could also be a smartwatch, could also be a connected toy, could be a connected car, devices that have Wi-Fi or Bluetooth capabilities usually are broadcasting their identifiers, their MAC address, Wi-Fi or Bluetooth MAC address, in order to allow you to connect to the known networks around you, or to allow your phone to connect with your watch and so forth. Venues like airports, stadiums, retail venues often use mobile location analytics technology, sometimes incorporated into their existing Wi-Fi routers, to sort of look out across the space and detect the number of devices that are moving around within a space and how those devices are moving, or to identify whether people are repeat visitors. So your MAC address might look something like this. Different device manufacturers have different blocks of MAC addresses, and so you can also kind of infer from this not just the unique person, but whether it was made by Apple or Samsung or Mattel or Fitbit. Smartphones today typically randomize MAC addresses, so there's a bit lessened of a privacy concern there, but this is very common technology to detect connected devices within a space.
We had a couple of questions
Awesome.
from the floor, so I'll come up so people can see. And Kara, if this is yet to come in your presentation, we'll pass on it. One question was, will IP addresses be addressed or considered as geo data? Should we take that now, or is that?
So I think the best place where IP addresses kind of fall in is this spot right here at the very beginning where I mentioned I wasn't going to dive too deeply into it, and I'm sorry to the person asking the question, but routine connectivity information frequently allows first parties to infer geolocation. So a good example of that is mobile cell carriers, but another really good example is websites by virtue of how the internet works, have to receive IP address. Whether they keep it is a different question, but IP address has to be sent and received within internet traffic in order for that traffic to know how to get to you, and vice versa. IP addresses are assigned by the local internet service provider, so they typically correlate with at least approximate geolocation, usually talking about the city or region level. They rotate over time, though, so there's a bit of a lessened privacy issue there. An exception might be sometimes blocks of IP addresses are assigned to specific institutions, so you might have an IP address that corresponds with a university, for example, which might be a little bit more specific than typical IP addresses. And then, of course, the ISP can match the IP address with your specific home and identity, right? So as per the ISP, you have privacy implications.
Anything you guys want to add to that? And there are data companies that sell information linked to IP addresses.
Maybe
Definitely.
I can add something, because this is largely about home addresses, or let's say fixed IP addresses, static IP addresses on a known location. When you walk around with your mobile phone, you will also have an IP address. And typically, that IP address, as seen on the phone itself, will stay the same wherever you are. So in some cases, an IP address is an indication, but some cases it is absolutely not. Now, these blocks of IP addresses of mobile operators are known as well, which means that all of these, let's say, IP geolocation services need to cater for that as well. But of course, on a mobile phone, you have other information available. So it can be an indication of location, but in many cases, rather crude.
Another question from the remote audience. If my mobile device is connected to my home router, is it collecting or communicating more granular geolocation data within my house? So I guess, does my device OS, or does an app that is leveraging the location services have some more granular information because it's connected to that local router itself?
Vis-a-vis apps, I wouldn't think there would be a difference. Simon, Kara?
So in the end, the app or the mobile phone will kind of observe radio and other signals around it. So if in your home there is a multitude of different radio signals, different Wi-Fi hotspots, for instance, from your neighbors, it may be able to be more granular. I can't exclude it. But I haven't actually seen this happen. I could conceive a situation in which it's possible, by virtue of the fact that you, especially when you're living in an apartment building, that that because of the fact that in your bedroom the Wi-Fi signal of your neighbor is not available while it is in your living room, that given the combination of signals you could make those inferences. I haven't seen that happen though, but that's just me. So I could conceive it to be possible.
There are companies that certainly do analysis to try to individuate individuals in a home, right? If you're all coming in through the same home router, there's obviously different patterns of activity, right? Parent one comes home at a certain time every day, uses the iPad. Oh, this is probably, mom or dad versus a teen or the like. And so, to the extent that sometimes there's a lot of discussion about households, there certainly are folks applying intelligence. I don't think they're relying on an IP address as such. So hopefully that's it. Okay, one more. And this one is, what about cameras? For instance, cameras in cars that might be detecting license plates or other known points. How is video of vehicles or other sorts of objects that are seeing locations or seeing unique points, license plates or fixed points? How is video starting to input into location in some way?
Absolutely, yeah. Microphones and cameras are just one more sophisticated type of sensor, right? So you can imagine with a camera the ability to detect a unique face, a unique set of characteristics of a person, or a unique set of characteristics of a vehicle. Automated license plate readers are quite common. My understanding is that not a whole lot of that is currently feeding into a lot of third-party uses yet. But certainly a concern for the future.
So the question is about use of NFC, in particular for public transportation now. A lot of people are using their phone, which would obviously signal a location-based event. Same with transactions in retail. Do you see that feeding into location services if it's not already being used? Or
I think Kara should take this one, actually.
I do see that as one of a number of areas that will expand, and the types of sensors are growing so exponentially faster than we can figure out how to ingest the data and make sense of it.
Here's one more question. What about sensors and other high-resolution images that might be identifying vehicle license plates and individuals from satellites? So are satellites in some way identifying unique individuals? I don't think satellites can see license plates. At least they don't seem like they should be able to identify license plates. But is this something that is part of the ecosystem? Yeah, there is obviously a very big ecosystem of companies and probably governments paying for intelligence about how things move around, right? Like Wall Street knows every ship and where it's going and if trade is up or down or what China is shipping to Australia, because that's all being, observed and turned into, intelligence reports that stock traders use and so forth. And so, there was an interesting a story about how everybody wants to know whether Tesla is going to succeed or not, and a lot of that is, are they actually making all the cars that they have committed? And so some of the companies that sell this intelligence were putting together reports about how many workers were in the Tesla factories at different hours, and therefore, doing some analysis. I've not heard, unless some spy satellites are doing this for government, of unique users being identified from satellites, but
I think this is a great question. The use of satellite imagery, that the costs have come down so much, and pretty recently I've seen a couple of companies where they're looking at trying to very quickly extract as much information as possible out of the satellites and figure out what sort of secondary use cases might be available. Would that be perhaps for the purpose of counting cars to determine the volume of materials leaving a port or that sort of thing? I do think that in the future it is certainly possible that we will see more secondary uses of satellite imagery in a location-specific context.
is it the case that for a long time, at least I believe in the US, since the government had control of this network, they were not allowing outside of, government intelligence or other type of uses, levels of granularity that were enormously granular for, I don't know, I guess, you could track where the president is going, you could track all sorts of things. Has that changed because of the fact that now there are commercial, systems that are not subject to sort of that mandate? Is that?
Yes, but I think it's been for quite some time now that we've had access to imagery at very granular level, less than 30 centimeters, I believe.
I just wanted to also add that we also have to, if we go back to location, it's also about what it does, the imagery, is that it increases accuracy dramatically, actually, I would say. So that's helpful. in actually, for instance, updating maps, which we've seen is the basis with all of the examples. But what it also requires you to do is think about frequency, because these satellites aren't stationary, they are in orbit, and maybe they capture once every whatever hours. So you also have to realize that although you may see it as images in a consecutive order, there is enough time in between for the world to change without it being captured. So it is always going back to be aware of what you have sensed in terms of where it was, when it was, how often it was, and how accurate it was. And that's very critical in every discussion relating to identification.
That's a good place to end it. I'm going to hand things over now to my colleague, Selke.
Thank you. So just to take a step back for a minute, we've been talking about now both passive and active sources of location-based data. And I'm going to dive into some use cases. But before I do so, I just want to set the stage for who the players are in the data sharing field. You may have heard about first party, second party, third party, and I'm going to try to clear that up a bit. So first parties are apps or websites that are directly requesting location. You can think that there is a direct relationship between the two parties. Or in the case of service providers, it could be a bike share company, a cell site location information provider. This is something where there is a direct request for location information. Third parties are those, for example, that provide SDKs, that is a software development toolkit, and that is a small piece of code that is used to build and power location-based services apps. And you can think of this as something that is integrated, an app that is integrated to collect location information. And that might be for location analytics or advertising purposes. But you can think of this as in a downstream context. So this is secondary use. Some of the uses of the first party data is to detect security threats, improve geo-awareness services, or to analyze trends, and also geofencing. Geofencing is where you actually put a fence around a location and say, okay, I want to look at all of those within a certain proximity of a certain area. Or I want to make sure that nobody outside of that particular fenced area has access. Secondary uses are for things like marketing, profiling, measuring ad effectiveness, and also data analytics, which is the area that I'm specifically working in at StreetLight Data. And this would be for things like transportation planning and smart cities. And now I'm showing some data. This is time lapse of location-based services data. This is GPS data and location-based services app-based data, time lapse, and it's a bit blurry, but you can see quite the volume of data over a short period of time. And if you look over here, you can see the different colors. The yellow, orange is commercial vehicles, and the purple are personal vehicles. And this is just vehicle and location-based services data. So this does not even include some of the Wi-Fi data and the other data sources that Stacey and Simon were talking about earlier. Oops. And now I want to talk about some of the use cases. In a transportation scenario, what are some of the questions that location data can help answer? Where do commuters live? Where do they work? What are the demographic characteristics of the travelers? And how do the travel patterns vary based on time of day or day of week? And what are the origins and destinations of travelers on particular roadways? These are all very interesting questions that planners look at every day. Going back for a minute to this notion of spatial precision, there is a very, very big difference between 300-meter accuracy, which you might get from triangulating cell phone towers, or 50 meters, which you might get with GPS, or 20 meters, something you might get by using a combination of the various sensors that we've been talking about today. And depending upon the use case, that helps determine which sources of data you need to use to meet your requirements. Some of the big transportation challenges that we're facing today are big shifts in modes of transport. Vehicle ownership the trends are going down. And if you look at the stats for the next 20 years or so, by 2045, we will see an increase in urban population of around 32%, and up to 27% more vehicle miles traveled, or VMT, and an increase of 44% in truck freight volume. That's pretty remarkable when you consider that infrastructure spending is not going to keep up with that. There's no way that it can. So there's this notion that, well, we need to figure out how we can solve these problems by using the data that we have available today and the new sources of mobile data that are coming out every single day. And this transportation challenge is really a very expensive and dangerous mystery. One of the big problems is that greenhouse gases are way up. And then, for example, if you look in the US, we have 63,000 bridges that are structurally unsound, and half of the US roads are under-maintained. So what do we do about this? There's a huge opportunity to use analytics to do transportation infrastructure spending. Here is another example of mobile data. This is Fremont, California, and this is literally just 5 minutes worth of data. The data that I'm showing here is navigation GPS location data, which comes from connected cars, and then the blue comes from mobile location apps, or SDK generated materials. And here is a specific use case I'd like to highlight. One of the big interesting use cases for using the mobile data is to look at transportation demand management. And this is a use case from Northern Virginia. where the idea was that there is no way that the state was going to be able to spend any more money on building more infrastructure. So the idea is to look at where are the highest volumes of short trips between OD pairs, that's origins and destinations, that could be converted to other modes of transport. So for example, in these short trips, is it possible that people could ride their bikes, or people could walk, or they could set up van pools? But the only way to do that was to actually scan or look at every single road segment in Northern Virginia. One of the best ways to do that these days is to actually use all of the mobile location data that is available, as opposed to spending money on expensive surveys that are only conducted every 5, 10, or 20 years, or putting road counters or strips out on every corner. Another example is from the city of Lafayette, California. And this particular town was experiencing terrible congestion in their downtown corridor. And what they were trying to figure out was, what are the trips that are causing this? Is it school drop-offs? Are these first or last mile commuters? So for example, people who are driving their cars to go to the train station to then take the train into the city, or people dropping off their kids at school. And traditional studies were not providing the answers that they needed, so the idea was, you know what, let's try to use these new sources of data. And it's a bit difficult to see the results, but here you have some pretty compelling information that shows, for example, 39% of the trips were between these two specific areas. The last use case I'd like to highlight is looking at origins and destinations in North Carolina MPO, that's Municipal Planning Organization. And what they wanted to look at was how groups of people, different groups of people travel. But how do things vary by time of day and day of week? So what they wanted to do was they wanted to look at something as an alternative to doing a traditional survey. Traditional surveys are where you literally send out a questionnaire to families and you say, keep a travel diary. Tell us about your travel plans and your travel behavior over X amount of time. And many times people do not even respond, or the information is very inaccurate. In this case, they were able to use the data coming from mobile devices in order to generate tons and tons of information to then figure out how to calibrate, looking at, by time of day and day of week, the characteristics of the groups of people that were traveling. And here you see a very easy to digest heat map. And that's ultimately what people want to see. People want to see a nice, pretty map that tells a story. And it's pretty remarkable when you think about the trillions and trillions and trillions of data points and that 5 minutes of data I showed you earlier, that you can actually take that and turn it into useful analytics to tell a story in one simple picture.
Questions for Kara
Questions?
from the audience or our live stream?
Go ahead.
Yeah, I would be interested in knowing all the business models that you just, or the use cases you just described, is that possible to be achieved to process data for statistical purposes? Or is that not sufficient when you just mentioned the drop on and drop off? Is that really possible to portray simply just for statistics, or is that not sufficient?
What do you mean by statistics?
Well, I'm linking it a bit to the GDPR, which depending on for which causes you are processing data, the privacy requirements are higher or lower. And especially when it's the purpose to create statistics, you can process such data, for example, without the consent of the user, vis-a-vis if you are processing it for other purposes than just to merely create statistics, you have higher privacy requirements.
I think that's a great question. And I would say, for the most part, these use cases go pretty well beyond just a use for statistical purposes. I would consider that maybe it is a part of it. Other questions? One other thing I'd like to add is that these use cases, none of these would be possible without the use of de-identification methodologies, which is what we're going to cover in the next section. Please go ahead.
I'm curious to know if the advent of IoT and other devices like that have created an environment where we're seeing a lot more accurate location data, or if the use of technologies in cell phones or cars is really driving more accurate location data. I'm just curious for your response to that.
So your question is related to whether it's what is driving the accuracy?
Yeah, so I mentioned before, I think Simon said, or Stacey highlighted, the additional tools that are in cellular devices. Rather than 5 different, being able to measure 5 different things, we have 15 different devices in our cell phone, and that increases and enhances accuracy quite a bit. And I believe in one of your examples you mentioned the ability to see vehicles at intersections, which triggers an IoT scenario in my head. And I know that there's a lot of kind of hacker and maker groups out there that are trying different IoT deployments of that kind, where you're using visual IoT devices to try to track some sort of event that happens a lot throughout the day. I'm just wondering if that is driving increased accuracy in location data sets that are being utilized by municipalities or businesses in some way beyond the increased accuracy and application of the technology in cell phones or cars.
I do think that the sheer amount and scope of the IoT devices is driving the further accuracy because of the combination and the interplay, the interaction of all of these devices together.
I guess one question is whether some of this is data that is available for all takers, all users, or some of it may be available for subsets of users. So by that, let's take the beacon scenarios that we talked about. So if I'm a retailer, I may be very eager to know how people move throughout my space, or whether Santa Claus is really worth a big sponsorship. Is he really driving sales, or are people just showing up to see Santa? Do they end up in a store because they came to see Santa, right? So you can see retailers or malls putting beacons and really leveraging that. They may not be eager for anyone else to be able to get that information, and so some of the beacon providers have methods where they are constantly, rotating. They may have, the ability to allow the mall or their partners to have access to that data, but they don't want everyone else being able to use that. There are others who say, well, hey, that's not fair, right? What a shame. There should be beacons everywhere because look at that GPS. Look what that enabled when GPS was only available to the government. Everybody wanted access to it because they said, look at all these different services that can be enabled, and then it, became a publicly, usable tool. So there are folks who believe strongly in the notion that every device should be able to situate itself. Why shouldn't there be a beacon to show you where the curb is, so every blind user can know where the curb is? Every vehicle, instead of having to, map the whole world and have only 4 companies who have that data, maybe, the government should create a beacon layer of the world, right? Now you can obviously see all the challenging privacy things that come along, with this, but you can also see how smarter infrastructure is something that, municipal players who are looking at safety and so on and so forth. Why should every car not know where the line is in the middle and know where, every piece of physical world is? So you can see, beneficial uses. But so, anyway.
I think
one
one
more question? Okay. Other than existing laws, now I think we're going to try not to be too much about law and policy, because there's just, our goal here is like, can we explain the nuts and bolts? But I'll just put out the question. Other than existing laws, are there industry standards or frameworks regarding the collection, use, sharing, analytics, and et cetera of location data? So I think we'll hold that, and those are the wonderful panels for IPP, or maybe we can talk about it at the end.
Okay.
To the other topic. Actually, the question you asked made me think of, actually I need to add an additional dimension next to the 6 I already mentioned, because I actually think that precision and accuracy are 2 different things. Precision is how close to reality am I, but accuracy is also about how trustworthy is the information. That's a different notion. Now let me give you the example. Galileo, the GPS system that's going to go live, has a public version in which has a certain level of precision which is comparable to GPS, but there's also a paid for additional version which you can, an additional service which gives you a higher precision. But the accuracy actually depends on how good your receiver is able to actually receive the information. And so there is a drive towards higher accuracy and precision because there's relevance in safety critical applications, for instance. So that's definitely a drive. But also, if you look at, for instance, these Wi-Fi databases, maybe the precision of Wi-Fi positioning could be better, but if the database is corrupt, the accuracy will be off. So that's why also one of the key elements of having multiple sensors is that it will allow, in some cases, the device to better detect and weed away these inaccuracies, helping to increase precision. So that's how this relates. We're going to step into this other realm of identification and de-identification, because one of the things everybody kind of these days knows is that location data, if you have a lot of information with high precision related to a single individual, but you don't know who that individual yet is, by inferring and combining with data, you can find out who it is, where he's been, find out that he's been at a red light district, he's been at a synagogue, and he happens to shop at a vegan butcher. So you can infer a lot of that individual. Yeah, so, well, I haven't seen anyone doing this, but you can conceive that. So when you want to use the data for a certain purpose, or collect it for a certain purpose, yeah, you could repurpose it fairly easily for different elements. So Cara talked about a lot of the, let's say, public interest purposes for which you use a lot of data of individuals, how they move around the world, which we can all think is a great purpose because it helps us, but the same data could potentially also be used to harm a lot of these people, or cause distress, or do things we don't want. So in order to help avoid that, that's why we can use de-identification techniques. And de-identification is not a black and white thing. It has levels of gray, I'll show you. And it's actually meant to de-risk the individual by taking away some of the capabilities of the data to be able to identify the individual easily. That's the kind of thinking here. Now, getting back to the discussion on law and statistical purposes, don't think that with de-identification you can completely take away things that relate to risk and harm. And I'll give you the example of this app, a sports app. There's a European one and an American one, you can find them on the internet, that happened to publish heat maps of where people who were running were actually running. No one was identifiable, really not. But if you plotted those heat maps, and Kara showed a few, onto the map, you could find out that in certain places of the world, all of a sudden there was quite a lot of running activity in areas you wouldn't expect them to happen. For instance, Afghanistan or Kenya. And those happen to be military bases. Military bases that in that respect could be uncovered and cause harm or other effects to those individuals. Currently, I don't think there's any privacy law catering for this. And this is where you get into the realm of statistical processing, aggregated results, maybe even the data was anonymous to start with, still potentially causing harm. But you could also argue, in other cases, it causes good because it allows road authorities to determine, hey, there should be a running track here rather than a highway. So it very much depends on context and purpose. And this is what makes it challenging and hard, but also hard because people immediately think of all of the bad things and forget the benefits that could also be achieved. So and this is also where de-identification can help to reduce that effect. Okay, let's go there. One key thing to remember. Everyone knows this, but this is very core to identification. You cannot have two objects at the same place, at the same time, two different objects. If you arrive at a conclusion with sufficient precision, there's an object here, and you have another observation, and there's another object here, then it must be me. So this is core to all thinking in de-identification, but also why it's so important to think in accurate, precise time, space, and so on. This is very key to keep in mind. Now, what is identity and identification? When we talk about these numbers, there's a lot of mathematicians and math going on. And what is important to understand is that when mathematicians or people good in math talk about identity, their concept of identity and what they see as identity may be totally different from what in social sciences or in philosophy is seen as identity. Identity is much more about the individual, how you know him, and so on. Whereas identity in math is actually about being identical. I'll leave the discussion related to twins up to you. And what's identification? Identification is the capability to find specific data, because we're talking about data, without ambiguity. How much ambiguity are we willing to still have? And what does that do to actually identifying someone? Do we actually have to identify someone, or do we have to have a 95% probability? This is also what makes it difficult. So, my definition of de-identifying is about adding ambiguity. And we have different methods. Do we have, we should have the slide. So, FPF have done, and you can find this online, And this is where you can see the, well, in this case, it's different shades of blue, the different shades of gray of identifying. If we talk about explicitly personal, so I can really identify someone, that's the easy part. We have direct identifiers, and they're still there. So there is a name, maybe as part of an email address. I can identify the individual. Explicitly personal. There could also be indirect identifiers. An indirect identifier, that's for instance an IP address of a home connection. It could be the MAC address of your phone if it doesn't rotate. It could be well, all of these kinds of direct identifiers. And here we talk about safeguards and controls. I skipped that one. So, explicitly personal, and this is also, going back to law, either directly or indirectly identifiable. I'll skip to the other side. Completely anonymous means that all of this is gone. But it could also be, and it's not completely gone, but still possible to, let's say, reverse engineer identity by combining with other data. That's not what this says. It says the data itself, as is anonymous because from the data itself, without any additional information, you can't infer the individual. That's why there's an additional level, aggregated anonymous, where that's no longer possible. We talk about groups of people. So that's the structure here. How do we arrive at this? And we can go over all of the ones in the middle, but I'll flag the one with pseudo-anonymous in a minute. I'm just going back. So what are the technical methods to do this? So we've already talked about replacing identifiers with pseudo-identifiers. That's pseudo-anonymization, which effectively means that I take your name and I replace it with a number. And that number, and then it's key, how do I generate that number? I could generate that number by having a random number generator and using that each and every time and then keeping a table of your name and the number. I could also use a mathematical function, for instance called hashing, which takes the name, pulls it through a mechanism which arrives at a number. Which means that each and every time I put in the same name, I get the same number, whereas in the other one, I just have a lookup table. That's critical because it says something about what the lifetime is of that pseudonym. If the pseudonym is generated through an algorithm, effectively that's eternal. If it's done through a lookup table, I can anonymize by throwing away the element in the lookup table. So when you hear pseudo-anonymization, there's a broad, I just gave 2 examples, spectrum of ways to do that. And the way it exactly is done decides the level of de-identification, and for that reason results in different risks to the individual, but also to different risks of utility. So one of the examples Stacey gave is the advertising identifier. I, as an individual on most modern smartphones, get to regenerate that identifier. That's a pseudonym, which is randomly generated, and the lookup table is on my phone. No one has access to it. I'm the only one. But that ID is sent out for all of these advertising partners, but if I break the link, the data could still be out there related to a certain period in time when it existed, but all new data is no longer connectable to that identifier. So that's the replacing of identifiers. You could also, of course, de-identify by completely taking away. That's the easy one. But you could also take away parts of the data itself, additionally. To give you an example, we saw all of this trace data. Suppose I have a trace from my home to my work. Not any data that actually identifies me, other than if you go to a map, find my address, go to a phone book, reverse lookup, find my name. So that's a way to re-identify. If you take away the first part and the last part of that string, it will become harder to find out it's my house and not my neighbor's house. So you first obfuscate. That's another method to work with location data. The disadvantage is that if you do that too thoroughly, what Cara explained to you about these origin-destination flows will not be as accurate anymore, because I may come up with wrong conclusions about the origin and the destination. So this needs to be tuned for the purpose. Another way, in that case, is adding an inaccuracy. We get now into this whole realm of what's called differential privacy, in which you do these kinds of methods of adding noise to reduce risk while preserving utility. And the last method is the aggregating element, in which you basically lift it at a higher level of abstraction, the data, which makes it harder to identify the individual. You actually start to identify groups. You are implicitly defining groups, which doesn't mean that the risk goes away, but the risk is effectively transferred to a group, which may actually in itself be an issue, as I explained with the sports app example. Yep.
That these are not necessarily mutually exclusive methodologies, and I try to think of this not in a linear or a binary way, because you can design a de-identification program that uses 2 or 3 or 4 of these methodologies and others as well.
And that's a very good point. It's not exclusive, and you need to design it for the purpose, so you need to think ahead. What is my purpose, and how can I have useful data while minimizing the risks to the external purposes? That's the key thing. This is also why when you start sharing data, it is so tricky in some cases, because you may not be in control of the purpose. So this is what FPF has come up with as the steps, which kind of in a way is a way to make it more easy to talk about the differences by applying all of the combinations of methodologies. So I recommend anyone to read through this. Just again, explicitly personal, pseudo-anonymous, and aggregated anonymous as the ends, and all of that are the shades of gray in between, which arrive when you start applying some of these methodologies. But now still, can you really have anonymous location data? I think you can. But it's very, very hard to get it right, because it depends, again, on the now 7 dimensions of location data. I have an example here to show you how that works. This is in the north of the Netherlands, a fairly rural area. That's what I'm giving you some additional information here. What you see is just traces of vehicles that have passed. I have, in this case, deliberately stripped away the endpoint so that you don't see, you can't do any additional information. That's a month. You immediately see the discussion related to accuracy and precision, because that car, because this is all cars, has really not driven through the fields. So something happened there, also important. What you can also see is, and this is on one day, there was probably a delivery vehicle going to this farm, because from the map you can infer this is a farm. Now, this data I would consider anonymous. Nevertheless, suppose there was a camera over here taking a picture of that car and its license plate, you could still re-identify. Now, up in the air, is this anonymous or not? Could you identify? Yeah, you can conceive it's possible. So what you need to do is then not only look at from a technology perspective, but what are we doing to avoid the data to be re-identified? So I have de-identified data, very thoroughly de-identified to the extent I can call it anonymous. But I also need to avoid the re-identification. That could be through technology. You could take organizational measures. You don't give the data away or keep it under control. Or if you do, you have contractual measures that prohibit re-identification. So then the question is, and I will leave you with that, is if data on its own is anonymous, but it takes a lot of effort or additional searching to effectively break the technical, organizational, and contractual measures, can we still call the data anonymous or not, legally? Thank you. Any questions? Yeah.
Thank you. Actually, to pick up on your last point, and then two other questions, very quick. One, as you just said, can you say that data is anonymous if it's a considerable effort that you need in order to re-identify? Isn't that exactly what the GDPR is saying? Question number two, I kind of heard a little bit the skepticism that you might have when you explained about pseudo-anonymization. Would you, from a company perspective, I can clearly say it from my company's perspective, we think this is really the way to go forward, because the identifier is intact. And with anonymous data, it's just not. And that makes it much more difficult to connect certain data sets and come up with business models. Yeah. And the last question, again, I'm sorry for the legal question, but do you consider that since pseudonymous data is still personal data, there is a room to re-identify in the end a person if the person consents to it? I always heard these examples of, let's say a cancer clinic that is specializing on treatment, and they are doing on a pseudonymous basis some big data analytics about certain cancer treatment. In the end, they say we want to be able to re-identify and contact those patients to provide them with certain results that we did in this analysis. Is that possible legally, would you say, or does it mean once I pseudonymize, it needs to stay exactly like that? Thank you.
So that's 3 questions. No worries. The first question is, isn't that what GDPR says? Yes, it is what GDPR says, but it's still an open norm. So it needs to be interpreted. So the question was, if it takes a lot of effort to do that, is it that's indeed what GDPR says. Now, so yes, that's what GDPR says, but it's an open norm. So it depends on the situation. It needs to be interpreted on the spot in context. So it very much depends on the data, and in order to do that, you need to look again, when it's about location data, about accuracy, granularity, frequency, all of that. Yeah, so that's important. Because effectively, that location trace could have been from a GPS receiver attached to a pigeon. And then the entire discussion is irrelevant because it's an animal. So that's a key thing. It's about context. So that's one. The second question was about pseudo-anonymization. Pseudo-anonymization is fits totally, in my view, in the risk-based approach of GDPR, the risks to the individual. Manage and mitigate, minimize the risks to the individual. So that's why pseudo-anonymization. But pseudo-anonymization in itself has various different varieties, and the pseudo-anonymization, which is based on hashing with an eternal effect, has a different risk profile than with a lookup table. So if we then look at what in the past, because there's a huge, actually, I would not call it legacy, but heritage of discussions on pseudo-anonymization in the medical industry, particularly in Germany, where in the medical industry, you really want to be able to go back to the individual to prevent the harm. That's fine. Then you use a different kind of pseudo-anonymization. Then in those cases, that for advertising purposes is not relevant. So that's important. So it is too general to say pseudo-anonymization is the holy grail for everything, because we need to know which specific parts are you using. Now then, going back to location data, in 2011 the Dutch Data Protection Authority published a report of findings, as it's called, on the way TomTom at the time used geolocation data. The method there, which is described in that report, was with a lookup table. And effectively, at that point in time, due to the specific context, in that specific context, the Data Protection Authority in 2011, based on the previous law, which isn't that different from GDPR, said the pseudo-anonymous location string can be considered non-personal data except for specific contextual situations such as low density areas, low traffic conditions. But the context of that was a lookup table for pseudo-anonymization and the lookup table never existing longer than 24 hours in that context. So there's an example that I know of very well of an interpretation of pseudo-anonymization or the definition of personal data in that context, given all of the technical and organization measures. So yes, it can be done, but it's hard. And you need to touch a lot of those elements. Getting back to the question of pseudo-anonymization, yes, do it. It de-risks the individual. And because it de-risks the individual, it de-risks the company. Because that's the essence of GDPR.
One quick question from the floor, and then we'll go to Henry. Again, this is probably a little bit more legal a question, but maybe if we tie it back to the conversations that we're having. The question was, what if the re-identification is something that happens as part of a secondary use, not the intended disclosed purpose?
Well, it's not impossible, but you need to first do the compatibility test. Is the purpose sufficiently in line with what the data was originally gathered for? And then you need to go into the specifics of the case again. So there is no, so the general answer, it's not impossible, but it requires work.
Or I guess I'd argue that if there is data that within any kind of legally permissible, technically feasible secondary use allows identification, it's probably data that might fail the test at the outset of being data that is de-identified. If we're looking at a data set that is de-identified, the purposes or the possible secondary uses, right? And the way we want to bring that into the initial de-identification analysis, right? We do need to consider, if we're going to argue that it's outside of GDPR, whether there are any legally and likely, feasible technical purposes, whatever those are, and that might make us fail at the outset. So I wonder whether the question is a valid question. Should I challenge the premise that you can be de-identified in your assessment because of the purposes of your collection, but then risk identification because of the secondary purpose? Is it a...
Yeah, but again, it boils down to the risks to the individual. So, so a risk of identification is in itself not a problem as long as the risks to the individual remain mitigated. So keep focusing on the risks to the individual, the distress, the harm, whatever you want to call it. That's where it is. That's one. The other thing is, don't see anonymous data as the holy grail. See proper data management as the holy grail and risk evaluation. That's, I think, more important, and that's why this is so good to be able to talk through those elements. That's basically my point here.
Henry, let me give you the microphone.
Thank you. So Henry Kolla from here, and we also deal with location data on a massive scale day by day, so I know what I'm talking about, basically. So my challenge for this would be that I think that you are not actually talking about anonymous data, really, by the definition of GDPR. So my counter challenge would be that you yourself started this session by stating that there can never be two objects at the same point in the same space at the same time, which means that it is not anonymous data anymore. So my challenge would be that the measures you have talked about here, they more point towards pseudonymous data rather than anonymous data, and I would kind of like challenge the audience as well as the panelists here that can really accurate and precise location data ever be treated as anonymous data? Because the measures you also talked about, technical and organizational measures, you don't need to put those in place if you're really talking about anonymous data, right? So actually you are talking about pseudonymous data because you think that there still is means to identify the individual potentially because of the same place at same time.
It depends, and we're flipping around between a legal definition and maybe a mathematical definition, because the legal definition in GDPR says that it is no longer there is this let's say test of how much effort in there, and what I'm basically doing is I'm saying is if I can demonstrate the effort to be very high, or the effort to be illegal. Legally, we can consider it anonymous. But mathematically, maybe not. And that's where we need to consider. Still, arriving from the conclusion that the data originally was collected with a human in the loop. That's why I'm making so the discussion could be if there are objects driving around without a human in there. So the automated vehicle that goes to your home without anyone in there. That data is not related to an individual. So that location trace can only be anonymous. Or isn't it because it drives up to your home? I don't know, we'll find out. But the point I'm actually making is because GDPR legally leaves the option of considering something anonymous if it's really, really, really hard, that's why I'm saying you can still have the discussion on de-identification, but don't have high hopes.
True, thanks. And one short point still. So I think we also didn't discuss the point that there is no like silver bullet for anonymization or de-identification, but you always need to kind of like analyze it in context. So
Yeah.
these measures, like you described, you need to define those for the purpose to then retain the utility, as you discussed.
Yeah, completely agree with that. Completely agree with that.
Henry, I think fair point that the primary collector is going to have this very hard test, even if they're anonymizing data. If it's very precise, there's this, real hard effort for that primary collector. But many primary collectors have a very strong basis for what they're doing and how they're collecting, right? Maybe I'm getting permission to be navigating someplace. And those primary collectors, however, then might actually be able to anonymize data. Obviously, at some very high level, we all agree. If they say there's 1 million people in the city today, right, we're probably not going to challenge that. But I think the secondary market is where the interesting legal questions start, where we clearly can anticipate. And then the question is, how granular can we get to unlock the value versus the privacy risk, and at what point do we pass at a GDPR? At what point is it, pseudonymous, and I can do some risk and discussion about the secondary purpose or the like. Anyway, so just
Jill, just to add a bit to that, the secondary purpose also in many cases is a purpose by someone else, a third party. So we have now cursed you all with the knowledge of location data, which hopefully makes more people aware of the power of location data, but also the risks of location data. And what I sometimes see happening is that location data is being used or claimed or gets in the hands of those who are not aware of all of these elements. And that's also very critical. And because that can trigger out of context surprises. And that's the key thing, I think, to avoid. Question?
Yeah, hi, my name is Dan. I'm a practitioner from Tel Aviv, Israel. There are a couple of points that I would like to raise. The first is that as to the identification of data, especially location data and vehicle-generated data, for example, I think that it's not only about identifying the tools or the measures in order to make it as hard as possible to re-identify the data. I think that a sound methodology to re-identify the data would be to periodically conduct re-identification attacks on your data set. That is, in my opinion, a sort of an essential element in maintaining your data de-identified, much like penetration tests for cybersecurity. So this is one issue that I would say I don't, as far as I know, there is no indication or specific indication under data protection laws, but in my view, this is an essential element. The other the other point that I would like to raise is, well, it's a sort of a question of can you really maintain data de-identified, anonymized on a user level? And I think that the recent CNIL decision, the French Supervisory Authority decision in relation to the to an edtech company called Victory, puts a great big question mark on this issue, because part of their decision was, well, that's to my understanding, that the combination of the ED-IDs and location data constitute identifiable information. And if you replace an ED-ID with the sort of an identifier that your system generates, then that ID, whether it's hashed or not, will identify a specific either object that is owned by a person or the person itself. In any case, it will be attributed to a specific person, even if it's hashed, encrypted, or gone through any sort of additional measures. You will always carry, when you keep the data on the user level, you will always have a sort of an ID. And when you combine it with location data, then at least according to CNIL's decision, this is identifiable information from a GDPR perspective.
To respond to your first point on the what I call motivated attacker test, indeed, just like security measures, you need to, if you apply risk mitigating measures, you once in a while need to reevaluate the risk, and one way to do that is indeed to do these attacker tests. Yes, I've organized those, and it's surprising what, with advances of technology, which is what we do, of course, what can be done. This is also why indeed it is a moving target, and effectively GDPR, in a way, it's not that explicit, but forces you to do so. So, absolutely valid point. Yes, good addition. On your second question, I don't believe the recent CNIL case was too much about whether or not it's identifiable, but much more about what is the subsequent lawful basis to be able to process. And their reasoning boils down to it has to be consent, it can't be legitimate interest. Yeah? Yeah?
More people.
Yeah? Okay.
Sorry. There is a specific section in CNIL decision that discusses the identifiability of the combination of ED-IDs and location data. Yes.
Yeah.
We have a conversation queued up with the CNIL staff who are on this case next week, so we'll drill into it. But I want to try to not have a law and policy session, because we will have those. We want to elicit from our expert the nuts and bolts.
There's a case even more on point that you can ask me about later. But I actually, to keep it on technology, thought that, Kara, you might be able to speak to the first question and your methods of de-identification, since you're in this exact position.
Yes. So on the de-identification methodologies, we use a combination of de-identification methods end to end, and with parameters that we adjust over time based on what happens with the users. And we've actually built in automated privacy and coverage checks. So every single study or analysis that goes into our web app has these automated checks that look at, is it sufficiently aggregated over time, over space? What is the land use type? What is the sample size? That sort of thing. And this is an example that goes to my point about using combinations of de-identification techniques.
Kara, if I could jump in here, how do you deal with this question of group privacy or group implications that Simon raised earlier? You were talking about the case involving a sports fitness app that inadvertently revealed the locations of military bases. How do you become aware of those things ahead of time?
I think that there is something to be said for the potential to identify people based on patterns that you discern over time, which adds yet another dimension to this entire conversation. I take a very practical approach to all of this, and I generally don't even get into the argument with people about whether or not it is possible to re-identify, whether or not it is technically possible, whether or not anything can be truly anonymous. And I like to think more along the lines of, I always have the motivated intruder test in the back of my mind to go to your point. And I would encourage everyone to take a practical approach. And for us, one of the best guides we have is actually that Future of Privacy Forum infographic. We have it in our office, and all of the employees can see it. And we're always thinking in terms of, okay, when the data comes in the door, where does it fit on that spectrum? And what are the steps that we can do in de-identification to move it in combination with other materials further along the spectrum to get as close as possible over here to the right-hand side, keeping in mind the particular use case that we're talking about. And we're not talking about user level use case where we need the advertising identifier, which is something quite different.
Question right over here.
My question is related to the conversation that we're having. As analytics has become democratized, made more accessible to less sophisticated parties through tools that allow for fairly sophisticated analytics methods, is there a similar effort that any of you are aware of to make de-identification as a domain kind of catch up to the low bar to access for analytics? And then relatedly, there are many organizations that have data that they know would be useful to the public or to universities. There's different cities that make information accessible, but many companies fear releasing their data because they're very privacy aware and they want to respect the privacy of the individuals that they have data on, and they don't understand de-identification or re-identification. So are any of you aware of resources that organizations like that can look to help them if they don't have the in-house capability to assess re-identification risk?
I'll just mention one thing. We have a grant from the National Science Foundation to work with companies who are interested in making data available to academics. Obviously, academics are increasingly interested in studying data that may be held by companies. If I want to understand the social media platform and their effects on individual, I may want to study that. If I want to, do my research, the data about whether a wearable is really making me healthier, or all the work that the Apple Watch is doing, or the like. And obviously there are significant privacy risks and ethics risks and different models where some companies do work with academics, others don't. So we have a foundation grant to gather up the people at companies who are interested in not the social good, but actually working with academics and collaborating to say, well, is the identification the issue? Is it the different data cooperatives? Is it ethics boards when this is research that may not go through typical academic ethics boards, right? There's a whole host of questions, and so that is a piece that we're working on. Okay, let me throw to
It combines a little bit with one of the questions I was going to ask the two of you, which was, is the result of some of these high-profile re-identification attacks and group privacy issues in the last few years that companies and data set holders are just no longer going to release those to the public, right? To your question. And the first question, I think, was, are you seeing de-identification tools hitting the market to sort of keep up with the pace of analytics?
I have not seen a lot of readily available de-identification resources, and well, that's one of the reasons why I point to this infographic here, because it captures so much in one page. On the issue of releasing data, let's say by the private sector, by the public sector, one of the tools that I have been directing my public sector customers to is the open data risk assessment tool that was developed collaboratively between the City of Seattle and Future of Privacy Forum. I think that provides a good framework to help governments conceptualize and group the types of data assets, and then perform a risk assessment to determine what is the potential for identifiability and what is the potential benefit, and do a risk-based analysis.
So that I'll mention, so that Simon doesn't have to do so. Uber has a tool that cities can use to take advantage of some learning. They want to understand impact on traffic and other data, and it leverages sort of a differential privacy assessment to make sure that the dashboard level data that the city leaders can look at to understand trends or flows is mathematically vetted to meet a very small number, and is an interesting democratization in some sense, in that they've sort of built the differential privacy process into a tool that then cities can end up using. But it is certainly a challenge. Let me let Simon get
just
in.
One addition. An area where a lot of these questions in this problem space have already also been investigated, also partially answered, is in pharmaceuticals medicine industry, where you have doctors who really don't want to give out the data because it's about their patients. So there's a lot of work going on there with models like trusted third parties, with pseudonymization technologies. There's a lot of stuff to learn from there, what works, what doesn't work. So that's one part of the answer. The other part of the answer is also that the interests are very widely. Why people want to share data or not want to share data. I know of a company, and I'm talking 2011-ish again, where that really didn't want to share any location data because it would give insight into their market penetration in certain areas of the world. So before you know it, you have information that is classified as financially sensitive. So there's a lot of these kinds of interests that come at play, which need to be managed. So the problem space is more complex than just privacy, I would say. But that's also not unknown territory elsewhere. But are there any clear-cut initiatives? Nah, not really. There are pockets of initiatives, which are good and we need to build on, but this is a new area to explore. So that's why it's very helpful that FPF is helping us with that as well.
And just to add on what Jules was saying, Uber has released, it was an open source project that they did in collaboration with the Cal Berkeley, and they released a paper that you can learn a lot about differential privacy and some other techniques to obfuscate data.
GDPR is perhaps supporting the market here a little bit. There are startups that are, certainly not widely available, but you've got the Privatar and others who are, at least for financial institutions and others who now have, a higher bar even to meet, are certainly starting to spend the resources, but there still obviously isn't a place to just take the information out of the box. But I guess once you appreciate the nature of every unique data set being different, who would have thought that what movies you watch in order would be something that could be used to identify anybody, right? But oh yeah, there's the IMDb database, so some set of people by chance are going to be in both those data sets, right? So you almost need an awareness of every possible, indirect lookup database that can exist at any given time. And again, there are de-identification experts who keep track of this, sort of thing, but every day there's some new set. So I suspect there'll never be anything out of the box, but perhaps there'll be tools that can guide you through the process. That's what we tried to put out with Seattle. We are at the time, so those of you who have places to go, none of us will be offended. I think the rest of us are going to lurk around, and I think we'll keep the camera rolling a little bit because we have about 60 or 70 so still in the remote audience. Let me give a final question. The question from the remote group was, is AI going to be the end of all these de-identification measures because it's going to enable such great insights? That was the question. I'll add to it, is quantum computing going to, because I think that's maybe even more of a risk, is quantum computing somehow going to smash these barriers because of the immense processing that is capable? Who knows? But let's see if our panelists have any thoughts on that.
I think that AI is going to be an incredible tool for helping us develop new sophisticated de-identification techniques.
The battle of the AIs. Any final thoughts from any of our panelists?
Oh, just that I haven't looked into quantum computing at all yet. So
Didn't you study that in school?
if you want to do a technology session on that, I'll be in the audience.
A future idea for a program, quantum computing, and what is actually feasible today versus what we're reading is happening, at supercomputer centers in theory. Stacey, do you want to wrap up? Our next session will be on EdTech and.
Sure, I can actually bring up the schedule real quickly here by scrolling backwards through about 1 million slides. The next session will be in alignment with CPDP in late January, first couple of days of February. We will have an exact schedule, date, time for you shortly, and the best way to find out about it would be to join our ongoing listserv, which you can find at fpf.org. Sign up and we'll send you an email as soon as we have a date and time for that.
And many of the ongoing classes are all going to be remote. We probably won't even have an in-person, but we'll have the panelists sort of joining virtually, and we're really trying to make it work for the remote folks. If you attend all 8 classes, you get a certificate from VUB, so you can put that on your wall. That's always nice to have. If you are also interested, please join our privacy book club, where we have almost 800-900 people around the world who are reading, because who can you talk to about these books other than the people in our community? But the reality is there's some incredible books out there that we all should be reading, and it's hard to keep up. But if you have an excuse because you need to read it by the book club event, the next book is called The Known Citizen by a professor named Sarah Ego. It's a little bit US-centric, but I think it's the European readers who are participating have told us that it's been phenomenally interested, and you can sign up as well at our site for that. Thank you to Simon. Thank you, Kara, for joining us. We'll see some of you during IFPT, and thank you for joining. And Stacey, thank you for making it all happen.